This conference will now be recorded.
Hi everyone, good morning. Today we will see a new concept in OSB called service virtualization. Service virtualization. Okay, so we'll discuss about this service virtualization concept. This is one of the important concept in OSB, guys. There are several ways we do the service virtualization. First, I will explain one small use case. Later, we will try to see uh, to implement the overall use case. Okay, a practical example. Done. If you see this diagram, okay, so let me pick one small use case. Let's assume there is a manufacturing application. There is a manufacturing application. I mean, there is an organization who do the processors manufacturing. Let's take the example of Intel. Okay, Intel is a manufacturing unit, right? They develop processors. So here I have one web service which will process orders for processors. I mean, Intel company will make the processors and different laptop companies buy the processors from Intel. Okay, let's assume Dell is a laptop company, Sony is a laptop company, HP is a laptop company, Asus is a laptop company. We have different laptop companies. They need processor. They will buy processor from Intel organization. Okay, so to process laptop orders, Intel has a software, Intel has a web service. Okay, if you see this diagram, we have a target system that is the Intel processors manufacturing system. Okay, let me cancel this. Okay, so this is the Intel processors manufacturing system. So this web service actually takes the orders and process the orders and do the needful. Okay, so let's assume this is some third party web service. It can be SOA, it can be Java, it can be .NET, or it can be any technology web service. Okay, it's a web service. But the requirement is there are several source systems want to place their order to buy processors. Okay, to buy processors. So but I'm not really interested to directly share my Intel processor manufacturing system web service. Intel processor manufacturing system web service, I'm not interested to directly share with my source systems. My source system may use different mechanism, different technology. Okay, they can use Java applications, .NET applications, or whatever applications they use. If they want to communicate with my web service, what they need my concrete wisdom. They need my concrete wisdom, correct? So but I'm not interested to share my actual web service access. I am not interested to share my actual web service access with my source systems or my client applications. Are we good? So I want to develop a service virtualization, a virtual service in between source system and target system. In between source system and target system, I want to implement a middleware service, okay, with the different virtualization mechanisms. Okay, let's see. Let's see in this middleware program, in this OSB program, in an OSB program, how we can communicate with target web service. We need to configure a business service, correct? We just need to configure a business service. In that, when you are configuring the business service, we need to download the WSDL. So that means your program, your OSB program, we need to configure a business service and we need to download the WSDL. So we have a local copy of WSDL. Is it clear till this point? This yellow color box, which I am calling as business service configuration in my OSB service. So here there are several examples I took to implement the service virtualization. So service virtualization, guys, we can implement in several ways. Several ways. Number one, URL virtualization. URL virtualization. Okay. Number two, you can implement data virtualization. Okay. And number three, protocol virtualization. Protocol virtualization. So we can implement service virtualization in three different ways. Okay, three different types of service virtualizations we can do. Okay, first thing, let's see this target service. This target service is a web service. It has a concrete visual, correct? So let me show you if it will be clear for you if I get the visual as well. Okay, let's assume your target service has a WSDL. Your target service has a concrete WSDL. I'm talking about URL virtualization. Your target concrete WSDL. Just an example, I'm just giving example. abc.com xyz, okay, Intel processing manufacturing system, question mark WSDL. Let's assume this is the concrete WSDL of your target service. I am not interested to share my concrete WSDL with the source system. I want to create a virtual service. Virtual service, okay. Virtual service in OSB. We can do this in OSB. Okay, in this virtual service, what I will do, I configure my own URL. My own OSB, we have the option, right? We can control the endpoint. We can control the endpoint. I can give anything. Okay, I will say IPMS slash one test question mark wisdom, something. I mean, this is the actual wisdom. This is the actual wisdom. Instead of allowing my source system or my customer to access this, I don't share this with my customer or my source system. I will share a virtual service, virtual endpoint. There is a duplicate endpoint. It's a kind of virtual endpoints. But what I will do, even though I implement my OSB service, a new OSB project, I don't write any business logic here. This guy will behave like a simple routing service. Simple routing service. There is no logic in this service. Simply, I use the same contract of Intel processing manufacturing system, Intel processor manufacturing system. I use the same contract in my first example. Okay, and I will build a OSB service. I will use the same contract. Observe here, whatever the target system we have, there is a WSDL for that. The same contract, the same WSDL I will use in my OSB program, the same WSDL I will use in my OSB program, but I will change the endpoint. I will change the endpoint, and there is no business logic in the OSB program. Simply route the logic. That's it. Whatever input you received, send the input to target application, target system, and whatever response you received, send the response back to your Dell application. Is it clear? So I don't have any kind of business logic in my OSB program, and my OSB program is going to use the same WSDL what is provided by target system. Same WSDL I will use. In that case, this is a URL virtualization. Only URL will be modified. I have a new URL for my OSB program. The new URL I will share with my source system. Is it clear, guys? So this is URL virtualization. There is no logic we implement. I will show you how to do this one. Okay. So this is URL virtualization. Then next thing, data virtualization. That means my target system has a WSDL. It has its own contract, but I don't want to reuse the contract in my OSB program. I will build a separate WSDL. I will build a separate WSDL in case 2. Okay, which needs, suppose if I go for a different contract, different WSDL, different request XSD, different response XSD, then what happened? In my OSB program, I need to implement a logic. Something like calling my target system, calling my business service by using a routing action or service callout action. But when I'm calling the target system, before calling target system, I need to transform the data. I need to transform the data from OSB input structure to target system input structure. Okay, and then invoke the target service, get the response. Again, you need to perform one more transformation, target system response to OSB response transformation. That means we need to implement two transformations here, request transformation and response transformation. So we are not sharing what is the data required for the target system. Okay, target system data we are not sharing with the, target system expected data format, either input or output or both. We are not interested, or we are, for some reason we are not asking the customer to provide expected request and expected response. Okay, so there may be some reason we are asking a different contract to the customer or our source system. Okay, in that case, the case two, data virtualization, customer will give you one format of input. That input is not suitable to our target system, so we need to transform the data as suitable to our target system. Okay, and then we perform the invocation with the transformed data. So target system executes the logic and gives you the response. Once we receive the response from target system, what we need to do? Again, we need to transform the target system response back to OSB response format. So we are virtualizing data format. Okay. So this is second type. Any questions, guys? Any questions? So in first case, in case one, we just invoke the target system by using routing or service call out. There is no need to perform any data transformation. In second case, we need to perform the data transformation. Request transformation is required, response transformation is required, because we are not using the same WSDL of target system while building the OSB service. Okay. And third, if you see the case three, I gave two examples here. Not only two, you can go for any number of more examples. This is protocol virtualization. So your target system is a SOAP web service, but let's assume your source system is not capable to consume a SOAP web service. They are not, they are using some technology which is not compatible with SOAP web service. Okay, and they are asking, give me a HTTP or REST service. Give me a REST service instead of SOAP web service. Then what we need to do? We need to build our OSB service with a different protocol. Internally, we communicate with our target system. So, but the client feels that it's a HTTP or REST service, but internally it is a SOAP web service. Okay, so the protocol virtualization you can do with any protocols like HTTP protocol, JMS protocol, file or FTP protocol, MQ protocol. We have so many protocols available in OSB. Either you go with protocols or you can go with adapters as well. In 12C, once the earlier OSB is an individual product, right? At that time, we don't have the concept called adapters. We have only protocol concept. Okay, but now when Oracle acquired OSB product and merged with SOA suite, okay, so all the adapters, most adapters which are all used in SOA, almost all adapters can be used in OSB as well. Suppose I take an example of REST adapter. So REST adapter will behaves like a REST service, right? So in OSB, instead of using REST adapter, we can also use something called HTTP protocol. HTTP protocol. Okay. So HTTP protocol and REST adapter, the protocol will be same. Okay. Without using the REST adapter, you can use HTTP protocol to build a REST service. Okay, I will show you. Of course, this HTTP protocol has its own benefits and drawbacks, and the REST adapter also has its own benefits and drawbacks. We'll discuss. So here, case 3, I just give you two examples. You can make your OSB service as a REST service. You can make your OSB service which can consume the message from a JMS queue. So this JMS queue becomes the connector between your source system and the OSB program. Internally, again, it's a SOAP communication. Okay, are we good? Any questions? Any questions in the service virtualization concept? So why we go for service virtualization? There are several reasons. Number one, we are not interested to share our actual system endpoint with the third party, right? Source system is a third party system, completely out of our organization. Okay, let's assume Intel is our organization. Intel has a software, it has a web service, and we are not interested to share our web service directly with our source systems or the client applications. Okay, number two, client system may be not compatible with our system. So our system is a SOAP web service, client system. Let's see in this diagram, HP. HP is using one software. They have their own technology. They are saying our system is not able to consume SOAP web service. So we need a different protocol. We want to go for REST services. We want to go for queues, JMS queues communication. We want to go for file-based communication. Okay, so sometimes source system is not compatible with our system. Sometimes our system we are not exposed for security reasons or some other reason. We are not ready to expose our actual system with the client, and we build the virtualization, virtual services, and we build virtual protocols, virtual endpoints, and we share with our client. Any questions as of now? You understand the service virtualization concept? This is very important concept, guys. Most of the OSB projects build service virtualization. There is a backend system which we are not interested to expose to the customer, and we build a virtual layer in OSB and we expose the service to the customer. Okay, this is the most used feature in OSB projects. In any OSB project, out of 100 projects, 80% of projects mostly use OSB to implement service virtualization. Okay, because OSB is lightweight, it won't affect your performance, your system's performance, and you can build a virtual service you share with your different clients, same target system, but you can expose different services for different reasons, and you can share the endpoints with the source system. Okay, so let me start this example. Before I start this example, so guys, I already have a Intel processor manufacturing system, which is I build it in SOA as a SOA web service. Let me deploy this program. I have this program I will share with you. I will keep the respective jar in the shared folder. We have a common shared folder, right? I will keep the jar in the shared folder. You can get the jar and you can deploy it into your SOA server. Let me deploy the jar here. So let's assume this is our target service, okay? Uh, Once I deploy, I will show you the request format, response format, everything. Then we start looking into our OSP programs. Okay, let me deploy the SOA jar. I have the jar on my desktop. Let me deploy it. You know the SAR file deployment approach, right? In SOA, I have a jar. I'm just deploying this. Click next. Okay, it is asking for SOA folder, default folder. Next, deploy. Deployment process is in progress. Even though I close this pop-up, but still in the back end, the deployment process will go on. Okay, anyway, I'm not closing this pop-up. I will wait till the deployment is success. It may take few seconds or few minutes. Okay, done. Deployment succeeded. Okay, now get the endpoint of this visitor of this service, not just the visitor. Okay, so this is the endpoint of this service. Copy the endpoint. This is our IMPS visitor. IMPS visitor. our target system. This is our target system, right? Okay. So I will say localhost. This is my localhost. Okay. So this is a SOA program. I'm using SOA web service as my target program. It can be any technology web service, guys. If technology is not really matter, whether it is web service or not, that's it. If it is a SOAP web service, it has a concrete system, irrespective of technology. Done. Now, so let me test this guy. You can test this guy from SOAP UI or from test console. Okay, let's see what it is doing. I just started SOAP application, SOAP UI. Anyway, let me try to test it from Enterprise Manager. We'll see. Okay, we'll do one thing. Mm, every time we start the server, the first attempt will be slow in Enterprise Manager. From there, it will be good. For instance, as internal process. This is the service we deployed, right? Just go to the service. I want to test this guy. Okay. So here you can see the request payload. Request payload. So what it is asking, what is the order ID, then customer full name. Let's assume Dell Corporation. Okay, Dell Corporation. See, customer full name, it has two parts, first name and last name, and I'm providing it as a full name, two parts of the customer. Okay, processor model, I want to buy i5 processors, and I want to buy 100 quantity. 100 quantity. Okay, you can see the same in XML view. Copy the request. I just copied the request. I want to have a reference. So this is Intel processor manufacturing system request format. This is the request format. Okay. IPMS response. Let's see the response. If you submit this request, you will get the response. Oops, invalid input arguments. Why? What happened? Order ID 1001, customer full name, Dell Corporation. This is the model I'm expecting i5 or something. 100 processors. Okay, so this is the input. This is the input of IMPS. Let's see the output. Just submit the request. Okay, so we again the test run was not run, invalid input arguments. Why invalid? Anything wrong? 2000. Okay, yeah. So we got the response. Observe here, we got an order reference number in the response. Order reference number, it's a system generated that application. I mean, our Intel processor manufacturing system is generating this order reference number, and of course, order ID and the customer full name, processor model, quantity, and we have a status. We got some status as an acknowledgement. There is a comment here. We received your order. Use order reference number for next communication. So this is a reference number. So next time, if we want to talk about this order, anything we want to get the status of the order or anything we want to know, we can use this reference number. They added some comment. That's it. Okay. So this is our output. Let's see the XML view of this output. So order acknowledgement. This is the output format. Okay. So this is our target system. This is our target system. This is the input format our target system is expecting. This is the output format our target system is generating. Okay. So this is the WSDL. This is the WSDL. The first example, our use case one. Our use case one is we want to virtualize endpoint to the customer. That's it. I mean, I don't want to share this WSDL. This is the actual WSDL, right? I don't want to share this WSDL with my Dell application. I want to virtualize this. I want to generate a virtual service, virtual endpoint, and share with my customer. So same input, same output I will use. Same input, same output I'm using. I'm not changing the input output formats. Okay. Let me go to JDeveloper. I will implement the first service virtualization use case. Okay. A new project. New project. I will go to OSB tire. So I will give the same name, service virtualization practice or something. Service virtualization practice. Some naming convention just for our understanding. Okay, so we got a service virtualization project. You can build your folder structure. It's your choice whether you want to build the folder structure or not. I always suggest to build a folder structure. Let it load. Okay, so earlier examples we saw, right, how to build a folder structure and how we can move the files from one folder, one location to another location. All that stuff we did the practice. So in this example, I'm not going to do all this stuff, but in general, it is strictly suggestible. It is strictly suggestible to build the folder structure. Okay. Anyway, um, I told you, right? It's just our choice. Okay, let me choose some folders. Let me create some folders. It will be pretty easy to manage the files if we have folders. Proxy service. We'll build business service. Transformations. If you have WSDLs. Okay, done. And if you have XSDs, any XSDs, you can also build a folder for schemas. Schemas. Or XSDs, whatever the name you want to follow. It's your choice. You can, I mean, all the folder naming convention is user defined, right? Right. So now, first I want to build a business service, guys. Let's right click on it. Go for business service. This is IMPS, Intel Processor Manufacturing System underscore business service. Okay. I want to browse the wisdom. Click browse option. So here we have the endpoint of Intel, right? Just browse it. Browse it. Wait for a few seconds. because our whole program depends on our target system. So first build the business service in this example. Come on. I don't know the reason. Sometimes it takes huge time. Okay, fine. In the application tab, in the text field, provide the concrete whistle. So this is the concrete whistle URL. Just say OK. Then I want to download this whistle into my whistles folder. Let me go to whistles folder. Okay. Done. I download the whistle into whistles folder. Say next. See, this whistle folder contains see some documents. These are all the documents it is going to import. Two documents it looks like. I think the second one is an XST. Yeah, second one is an XST. Observe here. Okay. Say finish. So we have separate XSD and wisdom. So XSD is imported into wisdom. Done. So we got the XSD and wisdom here. We got the XSD and wisdom. Say next. Finish. Finish. Done. So if we observe, we got one business service, we got one WSDL document, we got one XSD document. Of course, if you are not comfortable with the naming convention, you can rename them. When you are renaming the document, it is always suggestible to close the files. Close every file. This XSD, I will rename it as imps.xsd something, not move. Okay, let me move it first. Move. I will move it to XSD's folder, a schemas folder. Okay. So in schemas folder, I want to rename this guy. Schema. IMPS schema.xsd. Done. And then I want to rename the WSDL as well. It's your choice. It's just your choice. It's not mandatory to rename. I will say Intel processor manufacturing system BS.WSDL. BS is an easy keyword. Let me rename this as well. MPS BS XSD. I'm maintaining same naming convention. See, business service file, XSD file, WSDL file. Okay, just open the business service if you want. You can see now your business service is referring impsbs.wisdom. Okay, if you open the wisdom, go to source, see the import statement. Your import statement is referring impsbs.xsd. Okay, all the rename, we did the proper renaming and move the files. Done. Business service is ready. Business service file is ready. Business service component is nothing but a reference component in composite. See, I'm not using composite at all. I'm not using composite at all in this example, but we'll see how the composite will be affected. See, I'm not doing any changes in the composite, but the business service is visible here. I'm not using composite directly in this example. Okay, if you want, you can use it, but intentionally I'm not using. Right. So now I want to configure proxy and pipeline file. I need a folder for pipeline. So first let's configure the proxy file. I want to configure a proxy file, but I don't want to use a new WSDL. What I want to do in the case one, I want to use the same WSDL, whatever the WSDL is there for target system. Whatever the WSDL is there for target system, the same WSDL I want to use in my OSB proxy file. Okay, that means this is the WSDL I want to reuse. I want to reuse while building the proxy service. Let me do that. Proxy service. Okay, this is case one, right? IMP MPS underscore case1. So we are doing only service virtualization here. Okay. So go to WSDL, browse it, browse the WSDL. I want to browse the WSDL this time. I don't want to create a new WSDL, or I don't want to use a different WSDL. I want to reuse the existing WSDL. My service virtualization already contains an IMPS BS. I want to use the same one. Okay. And I want to generate a pipeline, IMPS case1 pipeline. Okay, IMPS case1 pipeline. Say next. Okay, so here you can see this, guys. This is the virtual endpoint. I mean, you can modify it if you want. You can modify it. But what I'm doing is I'm using it. I'm using the same endpoint. So case1 endpoint. This is how the case1 endpoint local host colon 7101 the endpoint question mark WSDL. See, this is the actual WSDL. Line number 12 is the actual WSDL. I'm building a virtual endpoint here. This you can customize however you want. You can customize this endpoint. Okay, right. So simply say finish. Now we got one pipeline and proxy service. Let me move the pipeline document to pipeline folder. Move the document to pipeline folder. Okay, done. Okay, go to pipeline, go to pipeline. So here I want to configure a routing action. Where is it? Activities are not visible here anyway. Right click on it. See, sometimes JDeveloper has issues. Sometimes it will not load the components here. So what we can do, we can right click on the start node, insert into, I want to use a routing action. I want to use a routing action. Okay, I don't want to build any transformations, nothing, because my target system request XSD, response XSD, my source system request XSD, response XSD, and WSDL. I'm using the target system WSDL in my OSB program. That's it. So there is no difference. So I'm using routing action. In the routing action, see how I configure it. I browse the business service. I browse the business service. See this business service. Done. And here you can see use the inbound operation for outbound. Use the inbound operation for outbound. I mean, for your OSB program, whatever the operation used, the same operation you can call in the target system as well, because we are using the same WSDL. Your OSB WSDL and the target system WSDL is same WSDL we have. Okay, this is the WSDL, and this WSDL has an operation. This WSDL has an operation called process. This WSDL has an operation called process. So we are using same WSDL for my business service and pipeline. Okay, so here what happened? Input received by this program, input received by this OSB program, that input XML stored into body variable. Okay, in the routing action, you no need to perform request transformation and response transformation, because so the input variable contains input XML stored into body variable. Routing action will use body variable as invoke input variable, correct? So you no need to do any data transformation, because the same data we are using between OSB program and the target system. So you no need to perform any request transformation here. Simply leave the body variable. Whatever input received by your OSB program stored into body variable, the same body variable go to your target system with the help of routing action. And target system executes the logic, and target system generates the output, and response will come back to your routing action. So once the response received by routing action, response will be stored again into body variable. So now body variable contains business service response. Business service response and OSB program response are same. So you no need to perform the response transformation here. Are we good? So this is the simple logic. Simple logic we built. Let's deploy and test the program. Deploy and test the program. You hope you understand why I am not building any transformations here, because we are using the same contract for the target system and the OSB program. So their input structure, output structure, everything is same. Okay, deployment finished. Now go to your service bus console, refresh it. This is the refresh icon. Okay, now you can see service virtualization. Test your pipeline. Okay, you can test it either from SOAP UI or from here you can test it, not an issue. We just want to see whether it is performing as expected or not. See order request, order ID, customer. See the same signature we got. Same signature we got. So this is the signature, this is the contract, this is the contract of your SOA program, right? The same contract we have in OSB as well because we are using the same wisdom. There is no miracle here. It's a simple logic. We are using same abstract wisdom in our OSB program, but the endpoint is different, right? So let me test this guy. Give some order ID, customer full name, okay, processor model, and quantity 100. Okay, that's it. If you execute this, what happened? This OSB program internally calls the SOA program. See, we got the order OSB response. See, this OSB response is exactly same as your SOA response. Yes, same structure of the data, right? Of course, you can go to the trace. You can see this is the input XML. This is the input XML, and the same input XML we are passing to business service. We are not doing any data transformations here. We are passing the same XML to business service, and we got the response from business service. So this is the response. This is the response from business service. And the same is coming back in your OSB response because there is no response transformation as well. We don't have any response transformation. So simply it will come back as the response. Any questions, guys? So here, what is the advantage? Why we implemented this service? Just to get a virtual endpoint. We got a virtual endpoint. If you see the proxy service, we got the virtual endpoint in this proxy service. Go to proxy service transport tab. If you go to transport tab, this is the virtual endpoint, a different endpoint. So instead of sharing the target system endpoint, I will share this endpoint with my customer. Okay, this is the virtual endpoint. So if you want to test your OSB program from SOAP UI or you want to share the endpoint with the Dell Corporation, this is the endpoint, line number 15. This is the endpoint we need to share with the source system, not the line number 12. Line number 12 is the actual web service, but instead of sharing the actual web service, we are sharing line number 15, which is a virtual endpoint. So we don't have any business logic. It will not affect the performance of our program. It will not affect the execution flow because it's a lightweight service and it is simply routing the request. There is no transformations and nothing. Okay, it's just a pass through. It's a pass through, right? Accept the input, send it to target, get the output, send it to source. That's it. Okay, so this is URL virtualization. We are doing URL virtualization. Any questions in this concept? Any questions? No? Okay, I will stop here, guys, for today. Let me stop the recording.